Hello everyone, and welcome. Today, we are diving into the fascinating world of continuity and differentiability. It might sound intimidating, but trust me, it's super useful, and we'll break it down step by step. Ever wondered how engineers design those smooth roller coasters? Well, continuity plays a huge role. Let's get started. So, what exactly are continuity and differentiability? Simply put, continuity means a function has no breaks or jumps, and differentiability means we can find its slope at any point. These concepts are super important for ICSE because they form the foundation of calculus and appear frequently in your exams. First up, continuity. A function is continuous if you can draw its graph without lifting your pen. Think of a straight line or a smooth curve. To check continuity at a point, the left-hand limit, right-hand limit, and the function's value at that point must all be equal. Now, let's define what we mean by a limit. The limit of a function at a point is the value that the function approaches as the input gets closer and closer to that point. Remember, the function doesn't actually have to reach that value. Next, we move on to differentiability. A function is differentiable if we can find its derivative at every point in its domain. In simpler terms, the graph has no sharp corners or breaks. Here's a crucial formula. f(x) equals lim h right pointing arrow o, f x plus h, f x. H. Let's break that down. f(x) represents the derivative of the function. H is a tiny change in x. F x plus h is the function's value at x plus h, and f x is the function's value at x. This calculates the slope of the tangent line. Now, let's talk about the relationship between continuity and differentiability. If a function is differentiable at a point, it must be continuous at that point. However, just because a function is continuous doesn't automatically mean it's differentiable. Think of a sharp corner. It's continuous, but not differentiable at that point. Here's a key rule. d dx x caret n equals nx caret n1. This is the power rule. It tells us how to differentiate x raised to any power. Important, this rule only applies when n is a real number. A common mistake, assuming continuity implies differentiability. Always check for sharp corners or breaks. Examiners love to test this with piecewise functions. Remember that differentiability implies continuity, but the reverse is not always true. Let's solve a problem. Q. Check the continuity of f x equals x squared at x equals 2. Solution. Left-hand limit equals 2h squared equals 4. Right-hand limit equals 2 plus h squared equals 4. f 2 equals 2 to the power of 2 equals 4. Since all three are equal, f x is continuous at x equals 2. Let's look at a real-world application, designing smooth roads. Engineers use calculus, including continuity and differentiability, to ensure roads have gradual curves and slopes. This prevents sudden jolts and makes driving safer and more comfortable. These principles are directly applicable to problems you'll see in your ICSE exams. Exam tips. 1. Always check left-hand and right-hand limits separately for continuity. 2. Look for sharp corners or discontinuities to identify non-differentiable points. 3. Practice differentiating various types of functions using the power rule and other formulas. In summary, continuity means no breaks in the graph. Differentiability means a smooth curve with a defined slope. And differentiability implies continuity, but not vice versa. All of this, AI notes, doubt solving, and practice tests for continuity and differentiability, is free on Synapse. Study smarter, not harder. Start free today at synapse.omups.in. Master continuity and differentiability for ICSE. Please subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.